Today we're going to talk about three things. We're going to talk about intervals of increase and decrease, and then we're going to talk about points of inflection. So just a couple definitions here. When we're graphing smiley faces, parabolas, there's a part of the graph that goes downhill and there's a part of the graph that goes uphill. So the section that goes down in height, that's called the interval of decrease. Whereas the section that goes up in height, and again this is from left to right, that's called the interval of increase. So you're going to learn how to identify intervals of increase and decrease today. Go ahead and move up here. Okay, so you can see that you have a parabola right here, and this is going to sound kind of funny, but this is how I like to envision it. I want you to draw a little B. That's my B, believe it or not. Draw yourself a little B up here. It's always got to be on the top left, so that's always where you put your B. And you're going to ask yourself, if the bee is flying this way and he's going to follow this path, what's he doing? And I would hope you would say, oh, he's going to be flying downhill first. All right? Now, he's not going to fly downhill forever. He's eventually going to change his mind. He's going to change his mind right here at the vertex. Then he's going to fly uphill. So you can see that the downhill would be considered a decrease in height, whereas the section on the right, he's increasing his height, right? He's going upwards. So when you go to tell me the interval of decrease and increase, what you want to do is look at the section of the x-axis where this takes place. So 3 and to the left would be considered the decreasing height. In other words, if I ask, where does the green section range from in terms of length? Well, it goes forever to the left up until 3. That whole section is downhill. So that would be at negative infinity, because we have to use a symbol for left. There's no definitive starting point. We can always push that bee back. But he will stop flying down at 3. And then after 3, he's flying uphill forever. So you're really just giving me the interval that represents this portion of the graph. So it would start at 3 and it would go forever. The bee is forever going to fly uphill. So I want to use 3 and pause infinity. So all of your stories will start from the left. So we start with negative infinity and they'll always end on the right. So they should end with positive infinity. Whether they're going up or down, we always start with negative and end with positive infinity because we're telling a story from left to right. Now, sometimes kids are a little confused. Mrs. Stoltz, why didn't you put a bracket on the 3? Because it's a solid dot. If you think about it, at 3 specifically, that bee is not flying downhill or uphill. He's just kind of hovering, right? He's leveling out. So for me, if something has a bracket, that means it's included as an answer. But since he's not actually flying downhill at that moment in time, I don't want to include 3 as an answer. Now, with that being said, if you go on to take calculus, there is a definition in calculus that kind of contradicts that thought process. So there's a little bit of a disagreement as to whether we should bracket the 3 or parenthesis the 3 because of that definition in calculus. And it's something that we can't even talk about today because there's a lot of stuff leading up to it. So some textbooks will use parentheses and some will use brackets. So it's ultimately up to you. Which team are you going to play for? For me, I'm team parentheses. All right, so we'll do the same thing here for letter B, but this time my B is going to start down here. He's not starting up anymore. So he's going to begin his journey by flying upwards. And he'll go up and up and up and up and up until right here. And then he changes his mind and he flies downhill. So again, your job is to tell me the section of x values where the bee is increasing his height. So he starts from the left and he keeps increasing until 3. So my journey starts as an interval of increase, negative infinity or left until 3. And then from 3 and on, he flies downhill forever. So that would mean 3 to positive infinity. This is the most commonly missed question that we see kids will see this downward arrow and they think they should write negative infinity. The downward arrow just means decrease, so that's covered. Your job is to tell me the section of the x-axis that goes downhill. So yeah, it is going down forever, but it's also going right forever. And when it comes to x values, we deal with left and right. So right forever means positive infinity. So good rule of thumb is to only use x values when you're telling me your intervals. You don't ever use y values in them. So sometimes that is a saving grace for students. If they're not sure which number to use the x coordinate of that spot. And you saw that in both examples, the bee changed his mind at the vertex, and that's what makes it a vertex. So since we only need the vertex, and we actually only use x values, if you think vertex is h and k, which of those letters is an x value? It would be h. X always comes before y, so h is the x value of the vertex. Hence, that's the only thing that you need. So down here, we're going to go ahead and we're going to compute h. Negative b over 2a, which would get me negative 2. We also know, because that 3 is positive, that this graph is a smiley face. And we know that b will change his mind at negative 2. So therefore, my journey is going to start as a decrease from the left until negative 2. So that's why I have that here. And then negative 2, and to the right, I will see an increase. So sometimes kids will get these problems and they'll say, well, Mrs. Stoltz, you didn't give me a coordinate plane, so how am I going to know? I need the graph. You don't technically need the graph, you just need an imagination. You just need to know what h is, because that's the number you're going to use in your answer. All right, if it's a smiley face, the story starts as a decrease. And if it's a frowny face, the story starts as an increase. So these would just be switched around, but it's the same thing every time. So you don't necessarily need the graph, you just need to be able to visualize what's going on. So I'm going to move on to some more complicated graphs. All right, we have not seen this kind of graph yet this year. All right, so we call this a polynomial function. More to that later on. But because it's not a parabola, we don't call these vertexes or vertices anymore. We actually call them points of inflection. Now, when you take Calc 1, you'll use inflection points more in that class. So it's always nice in Algebra 2 just to introduce you to, hey, this is what they look like and this is what they're called. Right? Those inflection points are important because that's where the bee changes his mind. What's always a good move is to write the x-coordinate of each inflection point here. So like this point is at negative 3, negative 3. So I really can't go wrong, but the x-coordinate is negative 3. The x-coordinate here, of course, is 0. And for this one, the x-coordinate is positive 3. So that's always a good move. That way you don't accidentally use a y value when you're going to write your answer, because it's a very easy mistake to make. So our story is going to start by going downhill. So we are starting with an interval of decrease. And that happens between the left and to that negative 3. Then the bee changes his mind and increases his height between negative 3 and 0. So that's going to be my interval of increase. And then from that 0 to this 3, between that time frame is another decrease. So when we have to add more intervals, we're going to use a u to specify we have more things in addition to this. And then we'll end the story as an increase. So from 3 and on to the right forever, we have an increase. Now I like to throw in domain and range because we haven't done it for a while, and sometimes when you teach increase and decrease, kids mix that up with domain and range. So I want to revisit what domain and range means. Domain means how far to the left does it move versus how far to the right. So in other words, is there a left endpoint or a right endpoint, and in this graph there's not. So you would just say negative infinity, infinity. We don't have a cutoff on either end. Range is the opposite. That means how low does it go versus how high does it go. So in other words, how low is the lowest point? You can see these are your lowest points, and they're both at -3. But there is no highest point, so it would just be infinity. That you do want to use a bracket for. -3 is included as a part of the graph, so we bracket that. So this is just kind of a brief summary of what we just did. What you did is you marked all the inflection points and you marked their x-coordinates. So something changes at those specific points. All you did is you went through and you wrote these intervals. Negative infinity, -3. -3, 0. 0, 3. And then 3 to infinity. You just wrote those intervals, and you just want to make sure that you have the correct decreases versus increases. That's really all we're doing. All right, so this is a very busy graph. So again, I'm going to take that suggestion of writing the x-coordinate on each point of inflection so that I don't accidentally use a wrong number. So this guy's at -3. This dot is at -2. This dot is -1. 0, of course. This dot, you don't want to say is 1. His x value is about halfway between 0 and 1, so we actually want to write 0.5. And this one's at 2, and this one's at 3. Now there is an extra dot over here. That dot is not an inflection point, so it plays no role here. We just ignore it, right? It's really just there to try to throw you off. So we're going to start the story with an increase. So from the left, the story always starts with negative infinity up until that -3 is where we see an increase. And then a decrease takes place between -3 and -2. So we switch over to decrease, and we're just going to go back and forth between these. So we have -2 to -1 increase, -1 to 0 decrease. Then we switch from 0 to 0.5 for increase. And then between 0.5 and this 2 is where we see a decrease. So we have one more of each. Our last increase takes place between 2 and 3. And then our decrease takes place 3 and after. But again, we always end the story with infinity, because even though it's going down, it's going to the right. We're interested in the horizontal sections of what's going on. All right, that down just means decrease. We already got that. We covered that. I want to know how long will it go down. It'll go down forever, not how far down it goes. All right, same thing as last time. Your domain has no left endpoint or right endpoint. So your domain is, again, all reals. Now in terms of the range, we have a highest point. It's right here. Right, but I don't want to use that 0.5 when I'm talking about height. That point has a height of 1. So my range is 1 and down forever. It just goes down forever. There's no bottom point. All right, so next graph, we're going to need to put our own dots on the points of inflection. So there's 2 of them. And it looks like we're going to have a decrease, an increase, and then another decrease. Now you want to be careful here. If you don't write the numbers above the dots, then you're setting yourself up and you might write the wrong number in your answer. The decrease takes place from the left until this dot here. So his x-coordinate is -1. That's what I need to have in my answer. Then our increase will take place between that -1 and this dot right here. And his x-coordinate is 1. So -1, 1 is my interval of increase. And then I'm going to decrease one more time from that 1 and then forever to the right. My domain, just like the other problems, I have no left endpoint, I have no right endpoint, it's all reals. And then my range, I have no highest point and I have no lowest point. It just goes up and down forever. So my range is also all reals. So when you look at this graph, I want you to note there's 2 points of inflection. One right here, one right here. This right here, this dot, that is not a point of inflection. So we have to just ignore that. It plays no role. All right. So what I'd like you to do is see if you can go ahead and identify the 2 intervals of increase and then the 1 interval of decrease. I'm curious if we'll use the correct numbers. So I'm going to have you pause the video, give it a shot, and then when you're ready to check, go ahead and unpause. Good luck. Okay, let's see how you did. Now this dot's a little iffy. It looks like it might be like between negative, I don't know, 7 and negative 8. I just rounded mine negative 8. It's really not that big of a deal. So my increase is from left until that negative 8. Make sure that you're using that and not 4. 4 is a height. We don't use heights for these. Then it decreases from that negative 8 until right here. And again, his x-coordinate looks to be about like negative 1/2. And then we'll finish with an increase from that negative 1/2 and forever. And don't forget you want to put a u because you have additional intervals in that answer. And just like before, there is no left end, right end, there is no lowest, there is no highest, so it's just infinities all around.